Good evening, everyone. My name's Malcolm Hackett. Welcome to our second Bushfire Resilience webinar of 2021, presented by Dr. Justin Leonard from the CSIRO, entitled Get Water Ready, Tanks, Pumps and Sprinklers. Bushfire Resilience Incorporated acknowledges the traditional custodians of the many lands from which you are joining us tonight and the Aboriginal and Torres Strait Islander people participating in this event. We pay our respects to elders past, present and emerging, and celebrate the diversity of Aboriginal peoples, their ongoing cultures and connections to the lands and waters across Australia. This webinar and the presenters are providing information, not advice. Every property and individual circumstance is unique, so it's your responsibility to seek advice for your particular situation. The topic of today's webinar may be sensitive for some people, and some services which offer support are shown on the screen. On behalf of BRI, I acknowledge the wonderful supporters and sponsors who have made these webinars possible. Bendigo Bank Community Bank branches, CFA, Nillumbik Shire Council, Safer Together, Rotary International Diamond Creek, and Davey Pumps and Irrigation. I'm the chair of the community company which owns and operates the 5 local Bendigo Community Bank branches. It's a for-profit social enterprise which returns up to 80% of that profit back to the community through community strengthening sponsorships. You've seen our signs around the Shire. While we support all community groups, the CFA brigades particularly important recipients because they feed directly into community safety and preparedness. Bendigo Community Bank sponsorships have made some big projects possible. In 2008, we helped Diamond Creek Brigade with $20,000 to buy a quick fill pump, which proved invaluable when the Black Saturday fires arrived. In 2008, we contributed $37,000 to Hurstbridge Brigade to purchase a generator capable of running the new station. We did the same for Wattle Glen Brigade and $22,000 for the observation tower in Kangaroo Ground. We've supported research and Strathewen Brigade to fit remote opening doors so they could cut their response times. The community banks contributed $20,000 to the purchase of a command vehicle for the local Yarra group of brigades, $12,000 for a slip-on in Kinglake West, $10,000 for a slip-on in research, $7,500 towards a control vehicle in Panton Hill, and so on. We've provided funds for smoke machines, for practicing inside houses, for infrared scanners, for large animal recovery equipment, communications upgrades, and all sorts of power equipment. We've contributed to the defibs in brigade vehicles and recently helped to put public access defibrillators on the walls outside Diamond Creek, Plenty, and Eltham brigades, as well as the Hurstbridge Bank branch. So you get the picture. The income from community bank customers banking has made a huge difference in their communities and to the aspirations and the effectiveness of our local brigades. The local community bank branches are proud to sponsor them and to contribute to this innovative webinar series. Now we've got some housekeeping. Thank you for registering and for submitting your questions. You'll also be able to submit questions using the Q&A button at the bottom of your screen. Our moderator will group similar questions so we can cover as wide a range of subjects as possible. But please keep your questions short, to the point, and on the webinar topic. We'll go to a poll question for you to have a think about. You'll get a little bit of time, and then I'll introduce our presenter. Justin Leonard from the CSIRO is again presenting for us tonight. We've received overwhelmingly positive feedback about Justin's previous presentations, and we're really grateful for his continuing contribution. Justin's understanding of bushfire attack on buildings and the threat to life is based on 26 years of research into modelling of fires, computer modelling of experiments in bushfire situations, and also in surveys of investigations after bushfire events. And as one of our presenters, one of our participants said some time ago, Justin really knows his stuff, and we're really lucky to have him with us. So over to you, Justin.
Thanks very much for that introduction, Malcolm. So yeah, here we are in seminar 2, and I'm looking forward to presenting on water tanks and pumps and spray systems for as an augmentation to our protection systems. So I guess the challenge with these types of systems is they're active. They're not passive systems like using the right types of materials that aren't affected by fire themselves. And in active systems, there's always the issue of, will they operate? Are they reliable? Will they work under the conditions? So let's move through both of those topics in this webinar. What we'll do is we'll start off with a bit of deep thought about where spray systems are appropriate and what they aren't adequate at all for. And then in the second half of tonight's presentation, we'll move into how to actually make them reliable and design them so they'll actually hold up during the event itself. So in terms of what can we use them for, I'll take you back to our favourite checklist that I presented and qualified in our first webinar series. And let's have a look at each of the attack mechanisms and see where water sprays are actually effective. So would they be effective at addressing the impact on a house from a large fire front and for radiant heat? And I guess the answer is yes. If you've got an inadequately designed house that's going to face a higher level of radiant heat and flame than it could normally withstand, then a very heavy deluge of water over those vulnerable elements can work. And I guess the amount of intensity that you need to deliver is constant deluge and a constant water film, and it's really only then you can expect things like the windows to actually survive the radiant heat and flame contact that it may be presented with. So quite a specialist system and very high water delivery rates that need to persist for the entire duration of that intensity. And if you have a look at fire trucks, they actually are quite specifically designed to survive that very intense peak of fire. And there's actually quite a lot of deliberate detail in the way these are designed. Not only the metal piping and sprinkler heads, but a very deliberate effort to put these spray systems very close to the surface they're trying to protect. So their principal design is actually to get water to the surface without being disturbed on its way, and to constantly deliver that water film during the entire process. If we move on to Ember Attack, the answer is a little bit more complex. So obviously, water spray is going to be very useful to address where embers land and build up on the external features of a structure. But what they're not going to be able to be effective in is preventing embers getting through gaps and getting into the cavities of the house, which typically stay dry during a deluge or being sprayed with water externally. So, you know, water spray systems on and around the house can help to wet down those surfaces and those external ignitions, but they don't necessarily address all the key spots. And I guess another key point here is, where do you actually put these spray systems to actually put water onto the areas that are most appropriate? I find this is a fairly interesting picture because it shows quite an effective sprinkler type, which is the impact sprinkler, which is quite good at delivering water to a great range or area in under strong winds. Any of the finer delivery that gets projected out actually just gets carried away with the wind. And you can actually see how much is being carried with the wind here by the presence of a rainbow in the foreground. It's interesting to see where the water does and doesn't get. For instance, the eave fascias in this picture actually appear to be quite dry. And obviously water delivered from these locations wouldn't necessarily, for example, wet down the windows. A more appropriate one for, say, wetting down windows or wetting the areas around the house and addressing the places where the debris might build up, like the fine embers might land, is to put these types of chopper sprinklers or impact sprinklers in around the periphery of your house and actually spray them back onto the house and the broader surroundings. And even if we put water on all of these items, it actually still, the water doesn't actually seal the typical gaps and entry points that embers can reach into the building cavities. So here's a real example of a typical ridge line. It's actually a ridge capping designed to keep the water out of a roof, even if it's driven at quite an angle. But that's the typical places where embers can move inside and actually ignite those ridge lines. So water sprays actually don't address this type of attack. And it's important to really address the key issue of what spray systems do not cover. They aren't a panacea for all things. They definitely miss quite a few things, this for example. Another obvious one is, well, they're not going to seal a gap at the top of a roller door. You'd actually have to wet down everything inside your garage to be able to use water sprays as an effective way to mitigate that type of risk. So it's really a complementary approach to deal with certain things rather than a comprehensive fix. So moving on to adjacent buildings and combustible objects, yes, they can be used, but like trying to deal with a large fire front with radiant heat and flame, it requires a lot of water and quite a specific design of spray system to either wet down the adjacent building or combustible element, or put enough water on your own house to withstand the heat load from that adjacent building or combustible object. Now, buildings take hours to burn down, and you would actually need the water at a very high delivery rate to persist for the entire time that that adjacent building or element burned. And typical elements like decking can require quite an amount of water, but can be also quite effective if you constantly wet those elements down. Vegetation requires a lot of water, and I guess that vegetation can quickly dry out once the water stops. Water on fences can be another approach, although obviously, once again, it's far better to move to a non-combustible fence or no fence at all. So surface fires, yes, this is a particularly effective and easy one to address from water sprays. because water will land and typically wet out these surfaces, an intermittent wetting of these surface areas will be quite effective at eliminating that as an issue. And that might be tan bark under windows or any horizontal surface where the debris blows up and starts those small fires. The last three on our list, like branch strike or tree strike, ineffective, and that's fairly obvious. Wind and wind-blown debris and the impact of those physical impact, not effective at all. And of course, smoke and smoke exposure, the spray systems are just not going to be effective in those ways. So that concludes the first part of the presentation. So I'll switch back to Malcolm and for our intermediate break.
Thanks, Justin. Let's see what sort of questions are coming from people. There's been quite a few appearing there. Must I have roof-mounted sprinklers or ground-installed ones just as good? How far away from the house should these sprinklers be set? Should the sprinkler water be hitting the house primarily or the surrounding ground?
Wow, we might have to break that down into a couple of sections.
Yeah.
So roof versus perimeter. So roof-mounted sprinklers are very good at wetting a roof. Roofs in Australia are non-combustible. So a wet non-combustible roof and a dry non-combustible roof are as effective as each other. Water sprays on a roof can put water into gutters. And the question is, what's the most effective way to get that water into gutters if you're trying to solve a gutter ignition risk? And probably the most effective way is to directly deliver the water to the gutter rather than try to pass it through the air, have it wind affected, and maybe not get to all the gutters under very windy conditions. So I would sort of question the efficacy of actually having roof-mounted sprinklers at all. I find that the perimeter sprinklers, ones out in the broader area of the garden projecting back towards the house, are potentially far more effective because they get in under the eaves, they get on the wall surfaces, and they deliver water to all those ground and surface fuels that I've spoken about in the previous slides. Do you want to remind me what the second part of that question was, Malcolm?
The ground installed ones, then how far away from the house should they be set, and should the water be actually hitting the house or just wetting the ground around the house?
Sure. So I guess all sprinkler heads aren't created equal, and they are all designed to operate at different pressures and have different throws. So I would start with thinking about the particular sprinkler head and definitely err towards those impact style. Look at the pressures and what you've got available, and we'll talk a little bit about water pressures in the second half of the presentation. And once you've got that sort of coverage distance, well, you know your magic numbers. You really should be trying to project water onto your house. It should impact the house. It should impact all the elements that you're trying to wet out and protect. So it might only be a deck, so wet the entire deck. It might be a combustible fascia on your house and eaves. We'll wet the fascias and eaves. It doesn't have to be constantly wetted, but an impact sprinkler that keeps coming around and intermittently passing is certainly fine for that.
Our next question, I think, concerns lots of people. What are the pros and cons of a petrol pump versus a diesel pump versus an electric pump with a power supply backup generator or inverter or whatever? But those three different sorts of pumps.
Yeah, so that's the exact question I'll be answering in the second part of this presentation, which is what is a reliable approach to pump and providing pressure. So I'll save the answer to that question for the second half.
Okay. Now I saw a few that were coming in. You've spoken about those sprinkler heads. Has there been much investigation of sprinkler types and fire protection systems that have actually worked through a bushfire situation that aren't theoretical, but they've really been seen working in real life?
Yes and no. A lot of domestic systems failed under, for instance, the conditions like Black Saturday, and they didn't necessarily fail because the spray systems themselves weren't adequate for the task. They failed quite prolifically because the petrol and diesel powered pumps couldn't handle the heat of the day and in some cases the heat of the day and the heat of the fire. So there's actually it's actually quite challenging to find the ones that worked and persisted throughout because they're quite rare. But where they do show up as being quite effective are metal pipe work wherever it's above ground, and very frequent spray heads either mounted on the house or in that perimeter array projecting back onto the house using an impact sprinkler are the key ones that really do work. So short distance fans on the house or distant impact sprinklers that keep coming past.
Someone here wants to know how safe plastic tanks are and how far around a plastic tank should be clear. In this case, they've got short grass around their tanks.
Yeah, so plastic tanks do fail quite prolifically in a fire, but the ones that do survive have nothing around them. And I guess short grass is about all they can handle, dry short grass. Anything at all beyond that, it could be a treated pine raised bed perimeter that forms the base that the plastic tank's been put on. It might be even just another plastic tank right next to it with short dry grass under both of those. It could be one piece of wood leant against the tank. Anything at all is enough to be enough to feed off the tank and cause it to fail and let all its water out. And that can actually present quite a significant impact to an adjacent thing, like if it's a tank next to a house, for example. So yeah, the tanks can survive, but you have to be absolutely fastidious to not have anything around it at all.
What's the minimum volume of water storage that's recommended to supply a sprinkler system for an average size, single story, 4-bedroom house, assuming you've got, fire pumps and sprinkler situation?
Yeah, it's a how long is a piece of string question, in that it's about what you need to target and protect. So there isn't a typical system for a typical house, because a house should ideally have passive protection wherever possible, and the few things that aren't economical to passively protect by changing them to non-combustible materials, etc. You could use a spray system, and then I think you basically have to go through and look at the water requirements for all the things you need to protect. If you attempted to say, look, I've got a combustible house, combustible fascia, and I'm not prepared to change it, I'm going to try and wet the whole thing down throughout a fire event, and it could be a typical single-story house, I would say you would need upwards of 25 to 30,000 litres of water to protect that house throughout its entire event. If it was, I don't know, say something like a Bell 19, Bell 29 type scenario.
Mm. Yep, that's a lot of water. And some fire events go for a long time, as we discovered on Black Saturday. You can have used all your water up before the fire even comes if you're trying to wet things down.
Yeah, and that's actually why the volumes are so great. You might spend 5,000 to 9,000 litres of that to get through the peak of the fire, but there's hours and hours of persistent deluge of embers that will keep coming. And under those conditions, things dry out quite quickly, and you need to keep wetting and keep defending.
Mm. Should a pump be enclosed or open to the air? And what about a petrol pump vapor lock? And should a pump have its own sprinkler?
So petrol pumps do have that problem and did prolifically conk out during conditions of say Black Saturday. So they can't, despite them being a firefighter supply pump, the engine side of that actually isn't that adequate to work at the 40-degree plus conditions running flat out under those fire conditions, let alone handle the Ember Attack, the radiant heat, and whatever other heat loads are applied on it. So they do prolifically cut out and in a lot of cases won't be able to restart. So they do need to be put in quite a special protected place to be much cooler than the ambient conditions and must be protected from embers and all those other things to have any chance of operating. And you can understand that that can be quite tricky. A steel enclosure can be quite hot. You really actually need thermal inertia around it, like a masonry enclosure, to really get to a point where you could get a petrol pump through one of these events.
Can you tell us what are the merits of these remote controlled systems connected, say, to your mobile in order to operate a sprinkler system around the perimeter or on the roofline of your home?
Yeah, so I guess that cuts to the heart of this passive versus active system. And I guess an active system needs to be turned on, and ideally it doesn't need you to be physically there to turn it on. I mean, the ultimate life safety strategy is not being at your house. So setting up a system that doesn't require you to be there to help defend your house by turning on your spray system, for example, is going to be prolifically better. So automated activatable systems, I think, are a fantastic idea. And they're certainly a step above the, oh, well, I'm going to stay until X time before the fire turns up, turn everything on and hope it continues for the duration, because that's another compromise you're making about your life safety by leaving it as late as you can to leave. So nothing's worth those life safety compromises. So I would say once you get to a point of having a reliable water storage, a pumping system, you should go that extra step and have it as an automated activation.
Here's a good question. I think it takes me back to my childhood a bit. Is it okay to fill garbage bins with water and have a mop handy and to put them around the house? And are plastic hoses okay?
So the old knapsack and mops are an extremely effective way to put out a lot of ignitions with very little water. And I think in observing the realities that the power shuts off and your mains water supply dwindles to nothing, and you're left with what's in your tanks and what you can get out of your tanks and what you've already filled up your rubbish bins and your bathtubs with, it really does come down to those being very effective strategies to get by, particularly around that sort of constant onslaught of embers and continued ignitions in the many hours after the event itself, when it has reached a point where it's safe enough to move outside and continue that defence. Plastic hoses invariably are burnt out and useless if they were out during the fire event itself. So the surface fires that sweep through take them out. They could be pressurized, typical plastic garden hoses, or they could be empty of water or not pressurized. They actually just fail when the surface fires come through and impact them.
I know some of my neighbours have as part of their fire plan that the hoses are rolled up and brought inside so they can go out and reconnect them later, hoping they've still got some water left to use. You've addressed that, the inadequacy of petrol pumps under those high temperature conditions. Do diesel pumps behave in similar ways, or are they better in that sense?
So the diesel doesn't cause vapor lock like the petrol one. So the vapor doesn't create the problem in the carby. So they're a bit less heat affected and can run to a slightly higher ambient temperature than the petrol ones. However, the diesel ones are just as susceptible to Ember Attack or surface fire as the petrol ones. So if the diesel pumps suck in embers into their paper air cleaners, it'll cause a flaming ignition of that paper air cleaner, and that will snuff out the diesel motor just the same as it would a petrol one. The diesel ones do have a slight advantage, and that is around the prospects of safely refueling them mid-fire. I would feel a little bit more confident trying to refill a diesel fuel tank than a petrol one, only because it's far less volatile and more difficult to ignite from Ember Attack. Although I would be particularly nervous in either scenario, because you're effectively trying to pour a fuel, diesel or petrol, into a tank on a very hot engine. And of course, if you splash diesel on a hot engine, it can burst into flames, and it can be up to a temperature where those embers can ignite and you could have a major problem on your hands. So it does flag the issue that, yeah, diesel's better than petrol, but the question of how big your fuel tank is and what your prospects are to refuel it are key considerations in the design of your system.
Are gravity feed tanks preferable over, fuel type and electric generators and so on, in case there's a power failure? And would gravity feed provide enough pressure for sprinklers?
Yeah, so that'd be pretty much the gold standard. If you had enough height to get your tank up above your sprinkler head level, then it's absolutely reliable. Like water, and if the tank's designed the right way, well, you've got water and it's at pressure, and you don't have to rely on any means like a pump to give you the pressure. Now, how much pressure you actually need is a question about certain sprinkler heads need certain pressures, but you can do a little bit of maths with heights and pressures, and you end up finding that around a fire hydrant really needs to supply pressure at around 150 kPa as an absolute minimum, and that equates to about 15 meters of height, pressure head height. So the tank needs to be 15 meters above your house to give you that equivalent level. So if you can get to that amount and be as good as a fire hydrant, then you're doing really well. If you come down less than that height, like if you're down in the 10 to 15 meter range, you really have to be careful about the particular heads and how the whole system will work for that lower pressure.
I certainly know from my property, having it, say, a 2-inch pipe feeding from the tank down the hill, the size of the feed pipe actually has an impact on how much pressure you're going to get at the bottom too. If you've only got a 1-inch pipe, it's going to be significantly less. Is it feasible to attach a larger external fuel container directly to a pump to get that that extra fuel tank size?
Yeah, most definitely, and I'd encourage that approach, and actually to remotely mount the tank like off the pump itself. That certainly avoids the additional risk of heating from the pump and the heat feedback, which is one of your problems with vapor lock for your petrol pumps. And it also solves the issue of vibration. So, trying to mount or mount a large fuel tank on a small pump that's vibrating is going to lead to fatigue and issues as well. So definitely explore that remote mounting approach. Obviously still needs to be above the pump because they're made as a gravity feed.
If you were to install a poly tank below the ground to connect to your tanks and supply your sprinklers, which are on metal risers, how deep should the poly be buried?
We've found that once you get around 10 centimeters below the ground, the temperatures are not adequate to melt poly in the ground, except in the event that you put a significant fuel load on the ground itself. So if you had a vehicle that burned, or a pile of wood, or a fence burnt above along that line, and it was only 10 centimeters below ground, then you might have enough heat. But the typical fine burning of things above ground is not enough to affect things. So yeah, minimum 10. There's a difference in certain soils and whatnot as well, but as a rule, at least 10 centimeters below the ground, unless you're going past something quite significant, then you must go a lot deeper.
I can add an anecdote to this from Black Saturday. Our supply came from a dam above the house, and the poly had been put in some years ago, and it weaved its way between pine trees. The roots of the pine trees caught fire. The poly pipe was about 200 mil in the ground, and it put holes in the poly pipe, and so we lost the. So I'd be urging people to go as deep as you can and stay away from other stuff like trees.
And that's probably a really pertinent example, because it's poly pipe full of water, pressurized by a tank, and the water pressure wouldn't have let up, but it's still melted through the poly. So you just can't rely on plastic hoses, even if there's water or flowing water inside them. They can burn through.
Yep. A shrinking experience, I can tell you. Can rigid plastic poly pipe be used for sprinklers as long as there's water in them? So there, you've just answered that question.
Solved that one.
Yeah, that's right. Now, I saw one over here. Let's see. I don't know, I'm just looking for another one. We've got a few. Yeah, I think here's a good one for would affect lots of people on the urban fringe. If our water supply taps off a fire hydrant line, how reliable will our water supply be if there's fire in our area and the fire brigade is in attendance locally?
Fairly unreliable, because the firefighters have an upper hand in that regard. They've got a pump on their truck where they can actually suck water out of the hydrant system. So when they connect up, they will want to fill their trucks as quickly as possible, and they'll actually pump out of the hydrant. And unfortunately, that leaves all the other hydrant outlets with little to no water. So you can also assume that and at some point that hydrant system is connected to the mains system somewhere, and that's connected to a pumping station that may or may not fail in its power supply. So invariably we lose mains pressure, the hydrant systems aren't adequate, and we certainly don't have any power. So we really have to think about our spray systems and the reliability of water supply. It comes back to tanks, dams, gravity feed on property, and reliable pumping systems.
Getting back to our pumps again, what kind of container should fuel be stored in, and where should it be stored?
You'll notice deliberately that fuel cans have a metal, typically metal with a plastic lid. And the plastic lid is actually what you would call the fusible link, that when that gets heated up, the cap itself melts and relieves pressure and lets the fuel vapor out. If it was a metal fuel container with a metal lid and it was heated, it would build up to an extreme pressure and then really catastrophically explode if it was heated enough. So that's the ultimate issue and compromise between what you should store things in. You should store it in a purchased specific fuel can that's designed for that purpose. Where you put the fuel can is another important question, and I would say in a shed somewhere remote on your property, and don't go near it during the bushfire.
Getting back to our sprinkler systems again, this participant was told that their copper sprinkler piping is unsuitable for bushfires. Will copper withstand the radiant heat and flames?
Yeah, I've found copper, and particularly copper with water in it, survives adequately in bushfires. So I would challenge that as a suggestion.
We'll get on with answering more questions later. Perhaps you could do the second part of your presentation, Justin.
Sure, and I'll have to present it in a particular way because the questions were so pertinent that they've probably answered half of the presentation. So how do we build a reliable system? So I guess there's three really key components to work with. We need water and enough of it. We need that water to come out at sufficient pressure to be able to push it everywhere. And it needs to come out through a robust pipe network and spray heads. So if we look at water, the particular amount and the way we store that water is absolutely key. So a large dam is obviously going to be a fantastic, reliable water source. A concrete or steel or underground tank is going to be a really reliable storage of water that can provide that water supply throughout. Noting that, I guess, once you get down to steel tanks, your challenge is that the heat that would normally take out, say, a plastic water tank is going to affect your steel tank, particularly above the water line. So if this is a drinking water tank, it'll actually have a coating on the inside of that steel that that tries to maintain that high water quality for your drinking water tank. Any of that metal above the water line could damage the drinking water plastic coating in that tank and render the tank useless for ongoing use for drinking water. But what it does do is that metal tank will hold water for the duration of your bushfire and therefore be reliable. Similarly, the metal tanks that have the very large metal tanks that actually have almost like a pool liner inside them, we've found that they're actually very reliable in a bushfire in holding the water the duration of the fire and making it useful for firefighter defense, but the amount of that lining that sits above the water line is vulnerable to being heated under the more severe fires and can burn or melt, but it doesn't actually cause the liner to collapse inside the water tank. So it actually does its job, but unfortunately there's possibly the price of a new liner and some upkeep for those tanks. There's probably only one type of metal tank that's ultra reliable and can handle quite a lot of heat, and that is a stainless steel tank. So it looks very similar to a normal corrugated Colorbond style tank or a gel tank, but the stainless obviously doesn't need that plastic inner liner to maintain that water quality. So quite expensive, but an interesting option nonetheless. And of course, concrete tanks do really well above ground and below ground. Under really high heating conditions, you can get some spalling of those tanks, so a bit of the concrete can sort of pop off on the outside, but in almost all cases, that's a little bit superficial and cosmetic, and the tanks are great during the fire event and can perform really well as a drinking water and firefighter storage tank after one, two, or many fires. I've already covered the details around the plastic tank, so I won't go into that one. I guess the type of tank's important, but also if there's a tank stand involved, the tank stand's obviously got to be adequate as well. So things like timber tank stands are vulnerable in fires and burn through and cause the water tank to collapse and fall off. In this case, we're looking at a steel tank stand, but unfortunately they've used that lovely space under your tank for fuel storage or timber fuel storage. That would be quite catastrophic to even a steel tank if you put that much fuel load under it. So let's move on to pressure and how we get a system to work. So a typical system I find when I'm doing these post-bushfire surveys or having a look at people's houses is we've got a tank or a dam, we've got a firefighter pump, and a system that gets it to the house. So this is a really typical system. So obvious major problems that we've already covered is the fuel tank is quite problematic. There's inadequate protection of the actual pump itself. It's going to operate flat out for X amount of time, might be half an hour to an hour, and need refueling. And they typically cut out under the worst of the fire conditions that present. So lots of issues, and I guess the functional nature of these types of pumps is that you've got to ideally put them next to the tank to make them work. They don't like having to try and suck water from a long pipe network, so they're recommended to put near the tanks. And unfortunately, out near a tank is out in the open and exposed. So and those tanks, here's an example of one of those pumping systems that's ingested embers during a fire, and it suffered a flaming failure of the inlet air filter that's shut the pump down, and that won't be functioning ever again. The actual ember screening of the inlet area is important, as is trying to get these pumps to operate under the really high temperature conditions. And here's a really good example of an attempt to prevent the heat transfer between the exhaust outlet and the inlet, and also the exhaust outlet and the petrol tank here. So this is going to mean that this pump's going to push through to a much higher level of ambient exposure before it shuts down. So this might get up into the mid 40 degrees Celsius before it shuts down. But obviously we've still got an issue about embers. So how are we going to solve the embers? Well, we could think about putting the entire thing in an ember-proof cabinet. In doing so, you have to put a lot of effort into having enough airflow so that the exhaust can leave that enclosure and enough fresh air can get to the enclosure, and the enclosure itself doesn't get too hot as an internal air temperature because it's kind of not able to evacuate that heat. The degree that you need to ember-proof a pump enclosure like this is as you have to be as fastidious as you would with your house itself. So absolutely down to the 2 millimeter gaps and entrance. And I'd probably give this enclosure about a 6 out of 10 for detail, because there's still gaps and areas where embers can be drawn into this approach. So it's still quite possible that that pump could shut down in an ember storm by sucking embers into the inlet. And I guess the other approach is, well, you can even try to cool the enclosure or provide some cooling to the surrounding area. And you can do that by putting a spray system on the enclosure itself. So like that evaporative cooling effect you get by using evaporative coolers in and around your house, you get a similar effect by spraying water around your environment. So this pump might now start enjoying a 10-degree temperature drop in what it feels the ambient conditions are. So that could also extend the performance of that tank, of that particular pump. What the spray systems won't do, though, is prevent embers getting to and being ingested by that pump. We see time and time again that a spraying water around the place just simply doesn't stop the ember storm. The embers don't suddenly go out because there's water around. There's so many embers around, you just cannot rely on spray systems to prevent the embers getting into that enclosure. And obviously, when you open that enclosure, internally, that enclosure will be dry for the same reason that your roof cavity or your wall cavities are dry in your house. So what's a better system to the typical one? Well, why not electric? So electric pumps can be far more tolerant. They can handle a lot higher temperatures. They can be mounted in situ or remotely from the tank. But obviously you've taken the engine, the internal combustion engine off the actual pump itself and replaced it with an electric motor. But how are you going to reliably provide electricity to that motor? And what you actually need is either a remote generator, which can be put in a far more convenient location any distance away from the tank. So there's a big improvement, that you've got flexibility for a really nice enclosure in your preferred location for your generator. Or you can think a bit more outside the square and think about a battery storage system and an inverter. And both of those things can be safely mounted in an appropriate shed or in your house itself, or in a basement. And of course, they can work quite synergistically with the solar system and whatnot. So it's a bit of a maybe if you're thinking about quite an advanced solar system and looking for a bit of battery backup and surviving through those blackouts, here's a sort of really obvious and interesting extension of that idea to move to an electric system. The other side benefit of having an electric pump system is that point that was raised in the questions about automatic activation. And it's obviously a lot easier to automate the activation of an electric pump compared to having a starter and a starter battery and whatnot to get an internal combustion engine up and running. your system. So I would say that that's inherently more reliable. And of course, you know, the gold standard system is to use some form of gravity feed approach. And if you're lucky enough to be in an area like Marysville that actually has gravity feed town water supply system, then you know, you can start to think about having quite reliable water pressure. That being said, Marysville actually had a failure during the Black Saturday events from its gravity-fed water system, and that's because a car actually burnt over a service manhole that was some critical valve in the system that shut the whole thing off. So just like Malcolm's pine tree root story for his main water supply, there's always potentially some weird and wonderful way you can take out an otherwise really reliable system. And as I mentioned earlier, you know, ideally, if you've got 15 meters of height between your tank and your house, that sort of gets you well and truly there. If you're less than that, then you're going to have to really think carefully about whether you can use the right types of low pressure sprinkler heads and whatnot to get an adequate system. But when you're designing those systems, it's about the pressure that you get at the end of the pipe, not the pressure you've got ideally supplying the system. There's always loss in a pipe. So if you are working around those margins of having just enough water head or pressure, you really need to really think about nice big pipes and having a low loss system to work effectively. And onto pipes and spray heads. So anything above ground, I would say, you know, metal is the way to go. You can go with the galvanized pipe approach, although the downside of that is they rust over time and end up sort of choking up that pipe diameter, you know, during that life. And that all comes down to sort of soil type and water quality and whatnot that's inside the pipes. I would say copper is really reliable, and I would put copper standpipes coming out of the ground with no problem. I've seen really reliable systems with copper exposed to direct flame contact, and it's fine. I would err against using timber, even if it's hardwood, as the backing post, like in this example, especially not treated pine, preferably not hardwood, more like a steel support backing pipe for your standpipes would be more appropriate. I like this design in that it's got like an all metal impact sprinkler on the top. And I guess you probably wouldn't expect these plastic fittings to potentially be there if there was a significant heat source nearby. Yeah, so something like this style of impact sprinkler, they come in all manner of forms, and it's really interesting to watch these in operation, particularly when farms are sort of irrigating their fields with these types of sprinklers under extremely windy conditions. They really hold up against the worst of the winds and deliver water irrespective of those wind speeds. And of course, you know, placement, we have to really think about placement and what we're targeting and whether they're going to be adequate. And the percentage of loss from even those impact sprinklers that we're going to lose to the wind, because anything that gets picked up and carried by the wind just simply isn't going to be effective for your house. It might be more effective to your neighbour, but it's more or less lost water once it gets to that fine droplet size and gets carried away. I guess there's other types of sprinklers like that are more sort of dispersive sprinklers. This is the example that's actually on the top of that pumping shelter. And what you really find is this is a really fine dispersive sprinkler. So under really windy conditions, this is going to have most of the water carried away from the area rather than deluge back onto that shelter or its immediate environment. And yeah, you certainly can't rely on that type of spray system to be persistent in that particular area, and you can't rely on that preventing embers getting to your pump approach. So I think probably differently about a more effective way to get water onto that system. And I guess the particular standpipes and the way they're protected is key. Even the threaded fittings between them, you really have to focus that on an all metal approach. And I guess there's a few places where you really do have to compromise and potentially consider using a flexible plastic pipe. And one of those is actually the entry and exit to the pump itself. So because the pump vibrates, if it's an internal combustion engine pump, there's quite a lot of vibration. And to deal with that vibration, you can't really mount a hard metal connection to that pump. It'll eventually fatigue through and break, and it's not recommended in the sort of installation instructions. So if you're going to have to use certain sections of plastic piping, like in this example, what we really recommend you do is wrap it in some type of high temperature lagging. This is like an exhaust wrap that you get from an automotive shop. So that's actually a ceramic fiber woven bandage or wrap. That'll prevent embers and heat affecting the plastic too much. And then the ideal finish is to then wrap that again with reflective aluminium covering that then repels the radiant heat and gives you a really good sort of protection for those limited areas where you really have to use plastic. And I'll leave it there.
Thanks, Justin. Let's have a look at how our first poll response about tanks measured up with your information. What do you reckon?
I reckon they knew a fair bit about what I was going to say. I guess the steel with plastic liners ranked fairly low, and I guess it's probably not common knowledge that the steel with plastic liner tanks that actually do really well in a bushfire, where people have seen to have given that a fairly low score. So it's definitely going to carry the water through the fire. You're going to have it all available. But yeah, you're up for a new liner under the worser conditions. So I would definitely recommend those types of tanks as an option, particularly because they also are the typical ways to get a really large volume for a reasonable price. Those really large sort of segmented tanks. And I guess below ground, I guess below ground of any type, provided it's sufficiently below ground, is a good way to go as well.
I have seen double skin steel tanks that sort of have an air pocket between two lots of steel with the liner on the inside. Have you got any information about how effective they are?
No, I'm not aware of that, but anything with a double skin is going to have a huge effect on mitigating the heat to the inner skin. So that sounds like a really good approach. I'm not sure what's the specific approach to going to a double skin design. Is that to keep the water cooler, or?
I think they're specifically for bushfires, the one I've seen. I think I saw it at a field day, and it looked pretty clever. Had a premium price, but it was probably still a lot, as you say, a lot cheaper than concrete because you could go up to those large volumes. I noticed someone did ask a question early on about, you haven't mentioned fiberglass tanks. Do they have the same problem as plastic tanks?
They have the same problem. They're in fact significantly worse than plastic tanks. So the I don't know if they're actually in production anymore, but occasionally you see a very old fiberglass tank, which is like two molded things coming together and a seam around the middle.
Yep.
They fail quite absolutely with certainty with a very mild exposure, so even more vulnerable than the poly tanks.
And the other thing that some people were interested in is the that shielding material. Is that like a thick cement sheet, or was it some special material in that, on that pump example that you had?
No, and a suitable material to do that would just be any cementatious board. Non-combustible cementatious board would be fine. Even if it's a relatively dry environment and it's protected from the weather, even some cut pieces of plasterboard would be adequate.
That's a cheaper fix. That sounds good. We've got a question here about during a long hot summer, water supplies are often low. At what point in the fire do I obtain maximum benefit from having sprinklers on? And should there be pauses during the sprinkler use?
Yeah, so I guess that comes down to the specific thing you're using the spray systems for. So we went through in the beginning of the seminar what you're really targeting the spray system to do. If it's to protect your windows from radiant heat during the peak of the fire, well, you need them on for the whole duration of that peak. If you're trying to prevent your deck from igniting from the ember onslaught, well, you need to intermittently wet that deck during and for hours after the event, possibly through the night. It really comes down to exactly what the purpose of the spray system is and what it's trying to protect will dictate exactly how it needs to operate to minimise the water use and achieve the outcome.
Is there a way that people can actually calculate the diameters required for, their manifolds and their connecting pipes when they're designing a sprinkler system, or do you have to go to an expert and get them to do it?
You can actually find some online calculators that help you size pipes and predict the amounts of pressure drop over the lengths and the elbows in a system. So I would say if you're really getting down to sort of nutting out or designing your own system, yeah, definitely find one of those calculators and do the end-to-end solution.
One person says that they went to a major agricultural supplier and looking for a, electric pump compared with a petrol pump, and they got brushed off. What should they look for in an electric pump? Where should they go even?
I get a similar reaction when people find out I drive an electric car.
Yes.
No, I would go to a specialist. So you really need to go to Davey or start leafing through the Davey catalogues and looking at the proper pumps. They're not going to be the types of pumps you typically use in a domestic supply. You're sort of going next level up. They're not necessarily expensive pumps, but you can find an electric pump to do pretty much any pressure or any volume task you need. You just have to work through that entire system and find, the expert pump suppliers like Davey. Davey have an incredible range, for example.
How do you This is an interesting question. How do you provide radiant heat protection if you've got plastic pipes supplying a pump from an elevated tank?
Oh, I think my last 3 slides pretty much showed exactly how to do that. If you had a really long run and you were looking for a really durable approach, you could think about enclosing it or shielding it with some type of masonry type exterior cover if you want a really long-term solution. But otherwise, the lagging and coating approach I showed there was pretty straightforward.
And this is a ripper of a question too. Does a ring main system have advantages?
So a ring main, I guess, closes back on itself. It does help to give you a more even pressure around the entire ring. So it's like you can be more effective that the last head in the network doesn't get the least pressure. You kind of, the ring main gives you a more even pressure delivery to all your heads. So
for sprinkler systems in particular, there'd be some advantage in that, you would imagine. Now, someone asked us, do the springs in a sprinkler head, weaken with heat? Do they fail or weaken?
It's been observed with sprinkler heads that weren't operational during the peak of the fire. So there's actually been flame contact on the sprinkler head, and that can weaken the spring and cause it to relax and then not function properly. I haven't seen any evidence that an operating sprinkler where the spring in that could get hot enough that it would fail.
And have you got any views on these trailer mounted fire tanks, say 1,000 litre, with a petrol engine coupled to a fire hose? Those sorts of firefighting trailers?
Yeah, so they were amongst the many that failed during the peak of the exposures in Black Saturday. The petrol pumps aren't typically enclosed on those trailers. A lot of those were backed up to dams and were used as, the set and forget, hopefully we'll still get pressure out of it type approaches. They're really, I would treat them more like the hoses. You've got to actually bring them inside and protect them in your shed, and bring them out and use that in the aftermath of the peak of the fire. And it would be quite a useful portable water source in that post-fire event, but don't expect it to survive outside, especially if it's trying to be operated throughout the peak of the fire event outside.
Do you know if there's any non-flammable fire hoses for domestic use?
So the typical roll flat hoses are flammable. They're made of a natural fibre. So I'm not aware of a completely inflammable one, no.
And this question also asks whether they should be kept on, do you bring whatever you've got, your hoses inside until you're going to use them?
Yeah, I guess you do, and if they're dry, they're going to obviously can burn through it. But correct me if I'm wrong. I guess it's a good one for the firefighters. Is those natural fibre hoses, when charged and wet, tend to be able to handle spotting and a bit of surface fire activity and don't burn through like a typical garden hose.
We'll see if we can get an answer from some of our fireys on that one. Now, one person here was concerned about the corrugated iron that was on top of that pump housing, and wondered about how well it was fixed in place, and whether that fire housing could be a problem in strong winds.
Oh yeah, most definitely. I would. It did look a little bit flimsy, but I guess the attention's in the detail. I'll have to zoom in and see how many screws were holding it down.
Yeah, yeah. Now, what about these fire retardants that you can apply? Is it worth spending the money on on fire retardants, or you go out and buy a better pump and generator and so on?
Yeah, so I guess that's referring to the hydrating gels and things that you could possibly spray over everything
Before the fire comes.
as a preventative. Well, they're a hydrated gel, and they're the gel itself before you hydrate it is possibly a vegetable oil-based hydrating gel or a slightly different type. Once they dry out, they're no longer effective. And in the case that they're vegetable oil based, they dry out, and then you basically have a house covered in vegetable oil, which isn't that ideal in a fire event. So it's really down to how much you get on, how thick it is, and how much it dries out during the event. And if applied the right way and are thick enough and are done in a short enough duration before the fire event, then sure, they might protect the elements you've put them on. The problem with them are numerous in that once you put them on, it's very difficult to get them back off, particularly in the event that that they get baked on in situ. So if you're going to invest in one of those approaches, you would look for the evidence of specifically how easy it is to get it back off and how benign for the environment it is. And of course, there's obviously the other side effect that you're going to get it everywhere and it's going to be slippery. So there could be some slips and trips issues.
Here's a home where there's vegetation 1 to 3 metres in height, 15 metres from the house. Is wetting that down before a fire, going to have an impact, reduce the impact when it hits that vegetation?
It really comes down to how wet it is at the time the fire turns up. So if you sort of try to imagine a Black Saturday condition and wetting out an elevated hedge or something like that, try to imagine how quickly that'll return to being dry again. Like we're talking 5% relative humidity, 60k winds and 40-degree heat. Like it's not going to be that long after you wet that vegetation down before it's back to its dry state. So it really comes down to wetting it down immediately before or during the fire event.
Yep. I think we've just about handled all. Oh, here we go. You've probably covered this, but it might be worth a comment. Plastic suction lines to the pump, are they likely to fail?
Yeah, so they rely on their rigidity. They're getting under suction means the pipe's doing everything it can, the water pressure is doing everything it can to collapse the pipe, but it's got plastic ribbing and whatnot in the pipe to hold it open. If the water inside it's hot or there's significant heat around it, then it might not be strong enough to keep itself open and it could collapse.
Will smoke on its own stop a fire pump?
Really dense smoke that has most of the oxygen consumed will cause the pump to drop significantly in power and possibly cut out, but it won't permanently immobilize the pump, so it might actually be able to be restarted.
And I notice here on the Q&A feed that a volunteer firefighter says the traditional canvas hoses will hold moisture and they're only likely to burn when they're subject to prolonged flame. So your beliefs there look like they were spot on. And I think we're just about there. There's perhaps one more here. The 50 mil outlets on most water tanks, are they actually big enough to do the job?
Yeah, once again, it comes down to the design of your whole system and what you're trying to do with your system. If you're talking about, you know, some of the biggest systems where you're trying to wet down an entire house, I would say you're nowhere near the mark with a 50 mil outlet. You might need multiple ones of those. Yeah, it really comes down to overall design and sizing. And that's, you know, over to the recommended calculators.
I think we're done, Justin. Thanks for another great session and some really practical information for people to digest and go out and act upon. Can I say to our participants, when you leave the webinar, you'll receive a short questionnaire that's designed to assist us with making improvements. Please respond promptly. And we really do use these. You'll notice I'm wearing my headset because people said last time my sound wasn't good enough. So we really do look to improve these experiences for people. Before ending, I'd like to acknowledge Max Garner and Alan Bloom and Peter Mildenhall and Mark Gravel, Fiona Mackin and Steve Jenkinson for their commitment and contribution to conducting the series of webinars. And special thanks to the CFA for access to the webinar platform and the behind the scenes technical assistance provided by Rowan Thornton. He's been fantastic. Thank you to our other sponsors, the Nillumbik Shire Council, Safer Together, Diamond Creek Rotary, Davey Pumps and Water Equipment. I'm sure after tonight's session, there'll be increased interest in what Davey have got to offer. And of course, if you are a local community bank customer, then it's your banking which makes this and the other community sponsorships possible. If you're not a customer, call in at one of our 5 branches and have a chat about how you can bank local. And if you're in another state or another part of our state, there's 300 community banks around Australia. They're all trying to do the same sort of thing that we are. We've spent 2 sessions looking at how to prepare your property. In our next webinar, we've got 3 highly regarded experts who are going to address an often neglected topic, which is your physical and emotional preparation, how to prepare yourself. And that's at 7:30 on Thursday, the 19th of August. So not a Wednesday, it's a Thursday. And we hope that you will be able to join us then. Good night and thank you all.